This is Darrell presenting Apple's Develop in Swift Fundamentals curriculum, Unit 2, Lesson 6, Loops. Swift provides several different methods for looping. In this lesson, we'll focus on just three: for, while, and repeat while. A for loop works with the range. In this case, we have a range of integers from 1 through 5 inclusive, and we specify that by starting with the first integer, ending with the last integer, and then we have 3 dots. The loop will assign each integer in sequence to a constant index, and then it will execute the code inside the braces with that index. In this case, it will print out this is number 1, then this is number 2, and so on through this is number 5. If we want to control how many times we execute a piece of code, but we don't actually need the index value while executing each loop, then we can use an underscore. In this case, the loop, the for underscore in 1 through 5, will execute this set of code 5 times, but it will not assign the index to a constant with each iteration. It'll just ignore the index, and then this particular set of code will print out hello 5 times. We can use for loops to conveniently iterate through every element of an array. In this case, we have an array of strings. It has 3 elements, and then our for loop for name in names, and then it executes this code. Names is the array and is plural. It is common in Swift to use the plural form to name arrays, and then we use the singular form for each index in each iteration. So in this case, the first time through the loop, it'll print out hello Joseph, and then the second time hello Kathy, and then the third time hello Winston. We can also iterate on each character in a string. In this case, we have a string with 7 characters, and we can iterate through the string. In this case, letter will be of type character, and then we can print out the letter is A, B, C, and so on. Sometimes you want both the letter that you're iterating on and the index position in the string. In that case, we can use the string dot enumerated, and for each iteration we will have a tuple, and the tuple will have the index value starting, which is an integer starting at 0, and then the letter of the particular string. We can also do this for elements in an array. So if we had an array, we could get the index of the array element and then the value of the array element. Here is a dictionary with 4 key value pairs. The key is of type string, and each value is of type integer. And then we can iterate through the dictionary, where each time we iterate through the dictionary, we'll get a tuple, where we get the key, in this case type string, and the value, which in this case is type integer. And then we can perform our code having access to both the key and its corresponding value. Dictionaries are not ordered, so there is no guarantee that unicycle will be first. For loops are great when you know exactly how many times you're going to need to execute the loop. However, if you don't know how many times you're going to execute the loop, it is good to use a while loop. In this case, we have an integer number of lives, which is a variable, and while number of lives is greater than 0, we will execute our play loop, where we play the move and we update our lives count. At some point, our lives count will drop down to 0, in which case the loop will terminate. When implementing a while loop, it's important to make certain that the condition at some point will become false. In this case, we're printing out how many lives we have, but we never actually change number of lives. As a result, this bit of code will result in an infinite loop and will use up 100% of the CPU on my computer until I terminate the program. Here's another way of implementing a while loop. In this case, I use a Boolean, still alive, and set it to true. And then while still alive is true, I execute this code. In this case, I actually have code which decrements the number of lives, and once my number of lives equals 0, still alive will be set to false, which the next time we test the loop condition while still alive will be false and the loop will terminate. One other observation about these while loops. They test the termination condition at the beginning. If still alive started out as false, then this code in between the braces would never execute. This is a repeat while loop. In this case, the code inside the loop is guaranteed to be executed at least once, and then at the end of each execution of the code is when you test the termination condition. Continue and break are control transfer statements. Inside a for loop, the continue keyword will stop the current iteration of the loop and go back to the beginning. The break keyword will stop the current iteration of the loop and will terminate the loop entirely and go to the end. In this case, we are using a counter to iterate from -10 to +10, but if the counter equals -9, then we skip the rest of the loop and do not print out counter. And you can see in our output, we skipped -9. And then we're also testing, after we print counter, we're testing to see if counter equals 0, and in that case, we will break out of the loop entirely. And you can see that our loop did not continue to +10, it just printed out until it printed 0, and then we reached the break condition and broke out of our loop. If you are following the Apple curriculum, now is the time to open up the Loops Playground and complete those lab exercises. This slide deck is copyright 2021 by Apple and is licensed by Apple under the Creative Commons Attribution Non-Commercial Share-alike 4.0 International License.